we're going to use the concentration of hydronium ion to track acidity and basicity relative to water. But instead of just using the actual concentration, we're going to use it on a logarithmic scale. This is going to make it just more convenient for reporting and referencing pH value or values of acidity. And so we're going to call this pH. pH is going to be equal to the negative log of the concentration of our hydronium ions. It's log base 10, so it's the log button on your calculator rather than natural log. And what this is going to do is it's going to take values for concentrations of hydronium ions, which will be very small, right? Like if it's basic, it's going to be less than 0.00000001, right? It'll be a really small value that you would write in scientific notation, and turn it into an easier to write number, like 8. So our range here we have shown, and our normal pH range is about 0 to 14. It can go outside this range. Something can be more basic than a pH of 14, and it can be more acidic than a pH of 0. It can be a negative value. And so you'll see those values in more extreme circumstances. For the most part, most of them are going to fall between 0 and 14. 0 being very acidic, and 14 being basic. And then 7 is going to be our what we call our neutral pH, right? This will be the pH of water, well, of pure water if we had it. And so at a pH of 0, our concentration of hydronium ions is going to be 1 molar. And so if it was 2 molar, that's when we would have a negative value. And at a pH of 14, we'll have a hydroxide ion concentration of 1 molar. And again, we could have a higher concentration like 2 molar, but it'd be larger than 14. And so here's our scale that we're going to have. So remember that in this acidic range right here, we have a concentration of hydronium ions that are going to be greater than 1 times 10 to the negative 7th. And in our basic region right here, we're going to have a concentration of hydronium ions that are less than 1 times 10 to the negative 7th. So here's just a little context setting for pH. So a 0.1 molar concentration of hydrochloric acid, again, this is a really common acid that we'll see in the lab and a common concentration. That will have a pH of 1. So that'll be pretty acidic. And if we had something like a 1 molar concentration of sodium hydroxide, that would put us all the way at 14. So that would give us a 14, a pH of 14. A 0.1 molar concentration of a hydroxide like potassium hydroxide, that would give us a pH of 13. So something that 7 would be neutral would be pure water. Now, if we pour some water from the tap, it's not actually going to be pure water. And so you'll usually see a slightly acidic pH in water that we take from the tap, and an even more acidic pH for things that are going to be like distilled water, something that we've tried to purify or remove ions from, because it's going to be easier for carbonate to dissolve with it, or carbon dioxide to dissolve to form carbonate within it. Some things that are kind of common stuff. All right, let's see, like pickles, Jessica pickle. So pickles, they're pretty sour. They're acidic. They're going to actually have a pH pretty close to 7. Something like a lemon, something that we think of as really tart, would have a pH closer to 2, not quite 2. Some common bases. Borax is something that is in my laundry room right now, and that's going to have a pretty high pH of about 9. Milk of magnesia is another thing that's in a lot of people's cabinets to help with upset stomachs. That's going to have a pH above 10. The other things that we're seeing here, like ammonium, that's going to be like a cleaning solution that'll have a higher pH.